So let's see applications and what we have discussed so far. We are still on what we call electrical energy, electricity, right? What is the effective resistance of three resistors with resistances 2 ohm, 3 ohm, 4 ohm, which are connected in series across a circuit? Now there is a technical term here, series. So these are resistors in what? Series. So they are not asking me to draw. But in case you want to draw, this is how the drawing will look like. They connect three resistors in series. So there is resistor R1, R2, R3. So R1 happens to be 2 ohm. This is 3 ohm, and this is 4 ohm. You see that? Now, if they are connected in series, what will be my total resistance? Total resistance in series. I have R total, that is R1 plus R2 plus R3. Let's go. R1, 2 ohm, 3 ohm, plus what? 4 ohm. What I get in? 9 ohm. So that is my total resistance in what? Series. Let's go. Next question. Two resistors each of resistance 5 ohm. It means all the two resistors have resistance of 5 ohm each. Are connected in parallel. Parallel. Not series. In an electrical circuit. Calculate their effective resistance. So nobody is asking us to draw. But in case you want to see how the drawing will look like, that is how the drawing will look like. So you see. Good. So this is 5 ohm, R1, R2 is also 5 ohm. So the current will be flowing from here. So a different current will pass through here, a different current here. But when you check this, it's the same current which will flow through. You see? Good. So for the effective resistances, that's what we call the total resistance. So let's look at the total resistance. Now when you connect something in parallel, that is the formula. 1 over R total should be 1 over R1 plus 1 over R2. Let's go. So 1 over 5 plus 1 over 5. Answer? So watch. The answer is not 2 over 5. Remember, you were asked to find the total resistance, not 1 over the total. Are you okay? So when you cross multiply this, you're going to see this. You agree? Then you find your R total. That is 5. You're going to get 2 over 5, right? Like this. You agree? So your total resistance is now what? 5.5 over 2. Or what? In decimals? 2.5 ohms. Remember, the unit for resistance is ohm. So you are looking for the effective resistance. So if the formula is like this, your answer is not 2 over 5. So it is this. An electrical circuit has a voltage supply of 12 volts. If the resistance in the circuit is 6 ohm, determine the current in it. So I'm looking for what? Current. Now they didn't tell me whether they are in series or parallel connection. If they should tell me in series, then maybe it will be 6 against something, right? Then I have to use a series combination to get it first. So they have calculated my total resistance for me. I don't need to do anything. It's 6, okay? Good. Now the voltage, the potential difference is 12 volts. The total resistance is 6 ohm. I'll be next to find current. Question mark. How can I find current? And I remember I have to quote Ohm's Law, right? So from Ohm's Law, V equals IR. So Ohm's Law states that let's go. So I want current, right? That is 12, the I and R 6. So you have 12 equals 6I. Right? So my target is the I, okay? Good. Over 6 over 6. So if your change of sign is not good, that is the approach that you'll be adapting, right? That is 2. The unit for current is ampere. Are you okay? In science, you don't write answers without units. Fix units there. Now let's look at this. Calculate the effective resistance of the circuit. This and this are in series. That is true. This and this are in series. That is true. But the top and the down are not in series again. They are now in parallel, right? It will take us to what we call circuit breaking. So let's go. So I'll find the series connection here first. Keep the answer there. Find the series connection here. Now the top and the down will be in parallel, right? And I break them. You understand? Good. That is how we break circuits. So I'll start by calling this R1, R2, R3, R4. R1, okay? Good. So let's see something. R1 and R2 are in series. Agreed? So I have to find the total there. R1 plus what? R2. That is 60 plus 30. What are you going to get? 90 ohm. Good. And you come to the down one, okay? R3 and R4 are in what? Are they in parallel? Wonderful. They are in series, right? So you find the total resistance there. So what they call this RT1 total, RT2 total, okay? So that is 100 plus 80. 181 ohms. Now the circuit reduces to this. That's it. Circuit reduces to Do you agree? I reduce the top, so that's it, okay? The down is also there. So now, is my RT1 and RT2 in parallel or they're in series? Good. Then I'll now compare the parallel connection. You see how we break circuits? Are you okay here? Okay. Now, RT1, RT2 in what? Parallel. So that is 1 over R total. What 1 over RT1 plus 1 over what? RT what? 2. Now that is 1 over what? 90 plus 1 over 180. Yeah, sponge. Okay, 1 over what? 60. Now when you cross multiply, right, you will end up getting R total to be what? 60 by 1. That is what? 60 ohm. Good. That is how we break circuits. State Ohms Law. What does it say? It said a current that flows through a section of a metallic conductor is directly proportional to the PD maintained across its ends, right? Provided temperature, pressure, and other physical factors are kept what? Constant, very long. You can just write this, it's accepted. Also, this is not a fish. It's not love or it's not stop ease. It's a proportional sign, okay? So V is proportional to what? I. So when you remove this proportional sign, right, you introduce a constant. It's not cocky, it's an R. That is how come this becomes what? Ohm's law. Are you okay? Again. Okay, let's go. Here. 3 cells each of EMF 2 volts and negligible internal resistance are connected in series with an ammeter, 2 resistors of resistances, 2 ohm and 6 ohm, and a key. Draw a circuit diagram for the above info. Let's draw. Just obey the instruction here, and you draw. Let's go. 3 cells each of EMF. So I can put the cells here. 1, 2, 3. You see that there are cells. Each of EMF 2 volts, 2 volts, 2 volts. Are you okay? Are connected in series with an ammeter. So my ammeter can be here. There is no series, it is series. How do you know? If the current is moving from the positive terminal here, right? Isn't there something through this ammeter? So it's series, okay? Series is not always so. This can also be series, okay? It's not the same path, are you okay? But this is not series. Because something different will move here, something different here. Are you okay? Good. So don't think series should always be so. It can also be so. With 2 resistors. Let's go. You see they are connected in series, right? So these are the resistors. Are you okay now? Now the resistors are 2 ohm and 6 ohm. This is a typical section B question, subjective question, right? Not objective. And a key. Good. So it means the key is open. How did I know? Because in B, I was told when the key is closed. So in my drawing, the key should be open. Because the question said, calculate the current in the circuit when the key is closed. It means your drawing should be portraying an open key. And how will you know? You remember that you were told that the voltage you measure across the external circuit of a cell on open circuit should be called EMF. Right? So when they say EMF, it means the cell itself is on open circuit. But when they say just potential difference, then maybe I should have closed the key. I'll be addressing the whole thing. So the key should be opened in the drawing, as you see here. Right? Good. What are we fighting for? I'm done with my drawing. Good. Are you okay with the drawing? Now what if you go and they say 3 bulbs? We're going to keep drawing cells here. What's bulbs? Right? This last 9 years. Last 9 years. Last 9 years. Right? It's just by the way. It's not so important. Let me think this. Some people are. Right? The science problem. Let's go on. Calculate the current in the circuit when the key is closed. Current. Okay, I don't know my total resistance, I don't know my total voltage. The cells were 3, right? So the voltage is not 2. So I have to get my total voltage. Are you okay? You put the voltages together, that is 2 plus 2 plus 2. What are you going to get? 6 volts. So that's the total EMF, okay? There were 3 cells. Now, I have to get my total resistance, right? And the resistance in series or parallel? Again, so resistance in series. So that is R total. What are you getting? 2 plus 6. What are you going to get? 8 ohm. Now I'm supposed to look for my what? Current. Look for what? Current. Good. Now I have to quote from which law? Ohms law. You quote from Ohm's law. Now from Ohm's law, V equals IR. V I R. So 6 over 8 equals what? I. 0.75 watts ampere. That is the current. Good.